So this video is going to be a little bit weird. What I'm going to show here is how to use several types of consoles, just like I showed and show on my demonstrations on qemu. And I'm going to prove that even though we use qemu for all kind of scenarios, then these are the exact same things we're going to do on all kind of hardware, like this laptop which is connected to this computer, or whatever is like on this bag, okay? There are all kind of boards over there. So what I'm going to do first, I actually just found this computer, so it's like a good experiment because it has this serial ancient connector. You don't get those anymore. So what I have going to do here is go on the grab menu, do E, and I'm going to change the line where I run the kernel. I'm going to just get rid of everything. I don't really need it, okay? So I don't need the terminal head off, I don't need the splash, I don't need the root file system. And the first demonstration I'm going to do is to just run it as is, either Ctrl X or 10. So I have this, all kind of messages, and boom. This is what's called the console. If I do like TTY, then I have here like dev console, and the console have this guy, which is like a screen and a keyboard, okay? Now, one of the first things I'm going to do is to open new virtual terminals. If I now go and do like Alt F2, Alt F3, it looks like I'm stuck, but I'm not really. This mechanism works. I just need to open or create like the virtual terminal before. So I'm going to do like OpenVT-C3, okay. I'm going to do also -3, 2. I'm also going to do here 4. And if I do now Alt F2, Alt F3, Alt F4, or I do change VT, and then I'm going to move to these terminals. Now, just for fun, I'm going to see what is currently running here. So now I have several shells, okay? I'm going to see what is my own process ID. So that's going to be 237, okay? And just to be on the safe side, I'm going to go and work like on another console here, okay? So if before we did TTY, and so that this is our console, then now I'm going to go and do TTY, and I'm going to see that I am under dev TTY2, okay? Now I really need two hands, so I'm going to try and make this work somehow. So hold on a second. So yeah, it's going to be a little bit challenging, so I'm going to either talk and like type and then pause and explain, because I don't want to record twice. As you see, it's not very professional. I'm not going to edit it or something like that. But I want to prove a couple of things, okay? So we already have a console that is working. We know we have input, we have output, and this is the default console that is the keyboard and the screen. Now what I want to do is actually to go ahead and do something with this serial cable that is going to be connected from here to this other computer that has two terminals here that I opened here, okay? So I'm going to go ahead and actually connect this serial cable, which is going to be under dev TTY0, okay? That's what it's going to be. Alright? Just for the hang of it, I'm going to tell you what is currently, like if I run a shell or do like any command, what is going to be the standard input and standard output and standard error of the command. So let's have a look at that. So if I do $echo $$, then I get the process ID of the current shell, okay? The current process. So if I look at this process under proc and its entry in the folder FD, like for the file descriptor, I can see that standard output, standard error, and standard input all refer to TTY2, which is our TTY, okay? If I went to the first virtual console and did the same thing, I will see that all point like to dev console, which is our TTY. So what I'm going to do now, I'm actually going to go and run all kind of commands that I'm going to redirect and prove that I can communicate with this cable, okay? So I'm going to first do some simple things, just do echo see that it works, do echo the other way, see that it works, then do all these two things together, and then like run a shell. This is usually being done when you do all kind of like remote shells, and this is going to be a proof that like the line works. Before that, we're going to fail because of very simple things that always happen when you set like serial. The things are going to be parameters like the baud rate, like the stop beats, and so on. So let's have a quick look what happens if I want to run a command like a shell. Let's just prove that if I run shell, another shell here, I will still have the same things. Okay, so I'm running here sh, that's another shell. Let's prove that. Echo $$, so it's 250, right? And now I'm going to once again go and see what is going on in proc $$ and fd, and of course they're going to point like to this, right? So I'm now going to get out of here because I don't really need it. Can do Ctrl D, and this was just a proof. I could make the video shorter without proving all kind of things. That was the intention, but it doesn't hurt. If you're following software, you're following software, and you always learn or like reassure some things that you already know, right? So now let's do something a little bit different. So the something that is a little bit different I'm going to do is that from this computer, my target, I'm going to cut into devtty as 0, which means that until I like hit end of file, then everything that I write here is going to get into whoever reads from it. That in this case is going to read from the devtty as 0. So let's have a look if this thing works, okay? Now I will not do cut first, I will just do echo, and there is a reason for that. I don't want it to get stuck and waste time. Otherwise I would need to kill the process most probably because of the failure we'll see in a second. Okay, so I paused and I forgot to resume. Never mind. What I did here is I did echo into devtty 0, okay? This is what I meant. And when I did cut here, I saw nothing. And the reason for that was the baud rate. Now, in order to see what are the parameters of the serial line, what I'm going to do is stty-f, that's the device path, devtty as 0. And here I can see that the baud rate is 9600. Whereas in my host, then it's 15200. So what I'm going to do is adjust one to the other. I want the faster one actually. So I'm just going to adjust here on this target. I'm going to put this, you can't see very well, but I do it. And the second time I check, then it's going to now be 15200. Here I still have the window that is like cutting and looking for output. And here if I go ahead and echo hello world, I will see hello world, okay? Now on the same way I can go ahead, do here for example, cut into dev tty s 0, and then everything I will write here will go to the other place, okay? So now I write 123, 1223 I wrote, and that's what I have, alright? So if I want to get out of here, then I can go ahead and do Ctrl D, and then it's going to hopefully get out of there. So that's what's going to happen. Sometimes, depending on what you do and what redirection you do, for example, if you redirect both standard input and standard output, you may not be able to get out, and this is where the virtual terminal, like Alt F1, Alt F2, Alt F3, and so on, are going to come to your help. And this is why I opened them in the beginning. So now I'm going to do something a little bit different. I'm going to show you how I am actually executing a shell. Now, the right way to do it is to open a terminal emulator that can MUX in one place, both the input and the output, and it knows like when you send input, when you send output, and works like great this way. What I'm going to show just to prove that like the input and output are separated, I'm going on this window to have the output where I have the cut, I didn't touch it, and on the other one I'm going to have the input, okay? So both are like in the host computer. My target is this laptop, and I'm going to go over the setup like right now. So check it out. So I did here shell, and I redirected the standard input and the standard output, not the standard error. Now look what happened on my output. I see like the banner of the shell, busybox and so on. And this is my input, where I didn't hit start yet, but now I'm going to hit, enter. And now just for fun, I'm going to do ls, and we can see the output over here, okay? We always see these annoying return control characters. So the reason for it is the way I defined my terminals. This is why it's not the ideal way to do these things. This is why you would want a terminal emulator. But now you can get a very, very like nice, not too hard exercise on actually implementing a terminal emulator yourself. You just need to take care of like the control characters and stuff like that. So I do not see anything here. However, if I do something that like will have an error, then I will see standard error here, like this thing not found. All right. So this is how I'm working like with the terminal, and now I'm doing like redirection of the shell from the target to the host, from the host to the target. And having proven this, then we can easily now see what's going to happen if we give another console parameter. So that's what we're going to do. So right now, let me get out of here. I'll just get to another terminal. It will be easier for me. The command line that we provided here was pretty much nothing, and I'm going to reboot it, use a proper terminal emulator, or I can actually use the exact same setup. And having done that, we will see that we have a serial console, and I connect remotely to my target, just as I would like in any bring up, or when I do a embedded development setup without a screen, without keyboard and stuff like that. So these exact things are what I do in my qemu or other emulator setup, and they are real and they represent the real world, as you can see here. Okay, so I'm going to now reboot it and we'll see the same thing. So having rebooted it, look what I'm going to do. Just like in the previous example when I just ran the console, now I'm going to have a serial console. So I'm going to once again put E to edit it. And now I will change the command line as follows. I will remove everything and put serial console and the baud rate and the other parameters that I want. So here are the parameters that I added. Console equals TTY-S0 and the baud rate. And on the other computer, this time I terminated everything from before, and I'm opening a terminal emulator. Pico with the relevant baud rate and connection. So now terminal is ready, and now when I boot it, let's do F10. I see nothing on this screen, but I see quite a lot on this screen, okay? So the console is now here. Now we have this guy. If I do TTY from here, then I can see that we have this dev console, and everything is good and everything is great. We have our console, all right? So that's pretty good. Now on the same note, I can go ahead and here, like I did not have anything working, right? So I can go ahead and open the virtual terminal from the console that I have, that in this case it's serial, but the console is the console, okay? I'm going to do open vt-c1 and 2, and whoop, there we have something, and 3, and I'm going to go now and see where I am right now. This is 2. Now did Alt F1, okay? So this is going to be 1. And that's it. Now I have both the serial console and a screen and keyboard, and I could of course have like a frame buffer and progress with it. And these are some of the things that I show on our mini Linux example build up on the busybox init branch. So I hope you learned something from it and enjoy.